Hello, good morning everyone. Today we are going to study about the renal physiology. In the renal physiology, under what heading we are going to study the topics? First, we'll study about the kidney anatomy, followed by functions of the kidney. Then again, we'll study about nephron. So what are the types of nephron and what are the functions of nephron? Again, we will differentiate cortical and medullary nephron. After that, we will do about the juxtamedullary nephron. Let's start with this anatomy of the kidney. So when we take the anatomy of the kidney, see, the kidney is like this. It has outer cortex part. This is the outer part, that is cortex. And the inner part is called as medulla. The inner part is called as medulla. So the outer cortex is always give a granular appearance. It will give a granular appearance. And why it gives granular appearance? Because of the presence of glomerulus, PCT, that is proximal convoluted tubule, distal convoluted tubule. Whereas the medulla will give striated appearance because of the presence of loop of Henle and blood vessels. Let's start with the inner part of the medulla. In the inner medulla, you will see many pyramids like this. So these are called as renal pyramids. The renal pyramid, the tip of the renal pyramid is called as renal papilla. So these renal pyramids will open into, these are the minor calyx. So these minor calyx will again open into the major calyx. Then again, this major calyx will open into pelvis, and the pelvis, renal pelvis, will open into ureter. So this part is renal pyramid. It opens at the tip. The tip is called as renal papilla. Here again the space after this is called as minor calyx. And this part is called as major calyx. This is called as renal pelvis. And it opens into ureter. So whenever the urine is formed, it comes to the renal papilla. From the renal papilla, it moves from the renal papilla to minor calyx to major calyx, from there to renal pelvis, from there to ureter by means of peristaltic waves. So the peristaltic waves start from the minor calyx at a rate of 1 to 5 per minute. So which drags this urine from the minor calyx to major calyx, from there to renal pelvis, from there to ureter, and the ureter ultimately end in the urinary bladder. And what are the functions of the kidney? So in simple word, kidney plays important role in homeostasis. Okay. So the most important aspect of kidney function is homeostatic functions. So what are the homeostatic functions? Plays important role. By a simple mnemonic, you can gather all the kidney functions. The mnemonic is wet bread. Wet bread. What W stands for? W stands for water, that is water regulation. E stands for ECF regulation. T stands for temperature. B stands for regulation of the blood pressure. R stands for release of renin. And E stands for electrolytes balance, to maintain the electrolyte balance. And A stands for acid-base regulation. A stand for acid-base regulation and D stand for diuresis, the most important function of the kidney. So these are the functions of kidney. So kidney plays important role in homeostatic functions. So what are the homeostatic functions? That is, I have given you a simple mnemonic, wet bread. What does the wet bread stand for? W stand for water. So regulation of water, regulation of ECF volume, regulation of temperature, regulation of blood pressure, and release of renin. Renin is released from the juxtaglomerular cells, which we are going to learn in the further part. And electrolytes. So whatever the electrolytes are present, like sodium, potassium, chloride, everything has been managed, everything has been maintained by kidney. And the most important function is acid-base regulation. Without this, our body can't survive the extreme condition or normal condition. And diuresis, removal of water.